Welcome everyone to today's webinar, OCI Container Engine for Kubernetes Enhanced Cluster Update. My name is Nikki Chen. I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today we'll dive into the latest enhancement in the Oracle Container Engine for Kubernetes. Also, just a quick note, we'll be sending the session recording to the same email address used for today's event. If you have any questions during the webinar, please drop them in the Zoom chat or in the Q&A area, and we'll be ready to answer them. We've also set up a Slack channel, OKE, new features in our developer workspace that you can access at the QR code or at the link on the screen. The channel will remain open after the event for you to contact us directly whenever you have questions. Today's webinar will be presented by Mickey Buxell, Brian Wood, and Tripping Wen. Without further ado, I'll pass it to Mickey.
Hey folks, my name is Mickey. I am one of the PMs for OKE. I'm excited to share some information today about new features and specifically a few slides on AI and machine learning workloads on OKE as well. So you can see our agenda today. We'll start off with why Kubernetes. This is more just to level set for those who may not be familiar with it. Then we'll talk very briefly about containers and Kubernetes at OCI. Next, we'll dive into Container Engine for Kubernetes and sort of the value prop for the service. The bulk of the presentation is going to be focused on new features, followed by a smaller section on AI and ML workloads. Then I'll pass it over to Brian to talk about pricing, and he'll pass it back to me to talk more about some of our existing customers, at which point we'll have some time for Q&A. So without further ado, so to begin with, what is Kubernetes? Kubernetes, very simply put, is an open source system for automating, deploying, scaling, and managing containerized applications. It is a container orchestrator. If you're someone who wants to leverage containers, which is kind of the de facto standard primitive for cloud native development, Kubernetes has become similarly the de facto choice for orchestrating those containers at scale. When I started working on Kubernetes back in 1.3, I feel like all of the conversations I would have really just had to define what Kubernetes actually was. And now jump forward to 2024, and for the last few years, Kubernetes has really become mainstream. It continues to see rapid adoption, but the nice thing is that most folks at this point have heard of it, have an idea of what it is and how it can benefit them. So that's helped me jumpstart some of my other customer conversations. What's also nice is that Kubernetes has shifted away from being really just for simple stateless applications. Now it supports things like ETL, batch shops, pipelines, and folks are starting to leverage this a lot for AI and ML workloads, leveraging HPC and GPU on shapes under the hood. Also, what's kind of cool for a database company like Oracle is that even databases run in Kubernetes. So how popular is it really? You got to believe me when I say that it is ubiquitous in the enterprise. It's actually the fastest growing project in the history of open source software, surpassed only by Linux itself. If you go back just a few years, only about 40%, so less than half of enterprise used it in production. This was back in 2021. By this year, they're expecting it to be greater than 75%. And by just 5 years from now, they're expecting that to be over 95% penetration. So clearly, this is something that's gone from not necessarily being niche, but being early in the adoption curve to something that is now very, very mainstream. So within OCI, we have a number of different services that customers leverage to tackle deploying and managing containerized workloads. You can see that there's sort of this chart here where you have on one end control and flexibility, on the other end agility, and then on the y-axis, whether it's managed by you or managed by OCI. So on the far left, we have Cluster API for Kubernetes. This is really just a DIY Kubernetes. It's you using OCI infrastructure, using our compute, our networking, our storage, our load balancers, but really just deploying and managing clusters yourself. Going to that middle section, we have a managed Kubernetes service, which is what we're going to be focusing on primarily today. And even within that service, we have a various number of options. So you have self-managed nodes, managed nodes, and virtual nodes, all of which we'll talk more about later today. So I won't dive too deeply in that here. And a new type that we're calling profiles or managed namespaces, which we won't really focus on much today, but provide an even more managed cluster experience. Further to the right from Kubernetes, we have our serverless offerings. We have container instances, which is not even using Kubernetes under the hood, but in fact is just a very simple platform for deploying containerized apps. And then also functions, which is another platform for deploying functions. So basically smaller applications that are fully serverless. There's not any sort of server running under the hood that you manage. They spin up and spin down. It's event driven. And that is the sort of the logical extreme of what we mean by agility. So one thing that's nice about all these different form factors we just talked about is that they're available all across the globe in all of Oracle's global footprint. So you can see here, these are the different data centers we have available at 68 today, and this list is constantly growing. In fact, I was pinged about an hour ago by one of my co-presenters saying that I needed to update this because the slide, which I got literally on March 1st, was already out of date, and there were 2 more regions added. So it's very cool to see that customers have access to these services all across the globe, in public data centers, in co-located data centers with other providers like Azure, also in newer forms like the compute cloud at customer, which basically allows you to actually deploy OKE on premises, or even the cloud appliance. So the nice thing is that our service is available for consumption in the public cloud or all the way out at the edge in your data center where you want to deploy it. So now that we've talked a little bit about Kubernetes and OCI, I want to dive more into our managed Kubernetes service, which we call Container Engine for Kubernetes. So OKE is managed Kubernetes running on OCI. Our goal is all the bullets that you see here. It's allowing you to reduce your operational burden by offloading the complexities of managing a Kubernetes environment to us, to the service. In doing so, you can ensure optimal operation of your environments. You can reduce the risk associated with it. And you can really trust us to handle Kubernetes at scale because we're doing it not just for you, but for a bunch of other very, very large cloud scale customers, and also for a lot of other OCI services as well. And in doing so, by adopting things like a managed control plane or leveraging virtual nodes, you can drastically improve your agility and flexibility. And then also, again, because you're trusting a cloud provider to do this rather than doing it yourself manually from scratch, you can rely on enhanced security. You know, our service is available in national security regions. We have to adhere to the strictest compliance standards. So you can really trust us to have your security best interests in mind. And one thing else that I would add is you also can lower the costs of operating Kubernetes at scale. You're not paying for control planes that you have to spin up and spin down, change the shapes of. You're using a very cost-effective service. And all of these things result in a lower total cost of ownership and a reduced effort and operational burden. They result in accelerating your adoption of Kubernetes, and then ultimately in improving your developer productivity as well. So a few more top level values of leveraging OKE. I think the one that's most important to me personally is that center point, which is open standards. So I'm actually a part of the Kubernetes upstream release team. I've been working on Kubernetes in almost every single release, going back to 1.22. And what's great about our service is that OKE is a certified Kubernetes conformance service. And what that means to you is that Kubernetes rich ecosystem, the whole cloud native computing foundation ecosystem, is available to you as third-party tools that you can bolt onto our service, which I think is really great. I think that the active community is one of the most important values of running Kubernetes. It also means that there's no vendor lock-in. So if you wanted to take your workload, lift it up and move it to another provider, or vice versa, move it from AWS on OKE, that is certainly possible for you to do. Because again, it's using the same open standards, the same Kubernetes API that you see available from other conformant distributions. So moving away from kind of the broad strokes of OKE, I want to focus on a couple of different types of clusters that we offer. So originally when OKE was launched, we supported what were called basic clusters. These are really DIY clusters that support core functionality, but in which a lot of the next level, the day two functionality is kind of left up to the customers. These clusters are full featured enough for people to absolutely run production workloads in them. Again, they were our core cluster type for literally the first 5 years of the service. And customers can bring any of those, third-party CNCF tools that are out there or their own configurations to really run whatever sorts of use cases that they want. But because a lot of that is DIY, it relies on the customer doing them themselves. We really think of these clusters as useful for prototyping, for testing and development use cases, for kicking the tires. They're totally free to customers. That does mean that there's a limited number available per region. And also because they're free, that means there's a service level objective, tied to Kubernetes API server uptime, as opposed to a service level agreement, an SLA, which would actually get you money back in the event of downtime. And the nice thing about basic clusters as well is that, if and when you're ready to take a cluster from that prototyping or test dev use case and leverage it for a production use case or take advantage of more of the other features available to enhance clusters, they're very easy to upgrade to enhanced. In fact, all it is you either call our API and then you have a fully online rolling upgrade from basic to enhanced, or if you're in Terraform, you change your cluster type from equals basic to equals enhanced. And again, you can apply it just like that. So there's no application rewrites needed. All you're doing is basically getting access to additional APIs that are restricted to basic clusters. Also, I should have said this earlier on, but if you have any questions about anything that I'm saying, please feel free to leverage the Q&A. And the folks that I have online will help us answer them. And also, I will have time for a Q&A at the end. So if there's any sort of outstanding questions, please feel free to ask me, and I'm happy to help out when I can. So enhanced clusters, which are our newer cluster type that came out a little bit over a year ago, are really the ones that we see as offering customers the full potential of managed Kubernetes on OCI. They have access to a whole host of new features. They have access to virtual node pools, which provide a serverless experience, cluster software add-ons with managed lifecycles that make it very easy to deploy software to your cluster, self-managed nodes for advanced use cases. That's what a lot of our AI and ML workloads are running on. Also things like workload identity that give you granular identity and access management, node cycling, which helps improve the operability of the service, and also access to an increased number of worker nodes. So being able to have a default support for up to 2,000 nodes in your cluster just by leveraging an enhanced cluster. You can have as many of these as you want in each region. And they are also backed by a financially backed SLA. So if you ever incur downtime, that's something that you actually get money back from us for. All right, cool. So now that I've introduced those two cluster types, I wanted to dive into some of the new features and also just show which ones are basic clusters and which ones are enhanced. So to begin with, I think one of the most fundamental parts of the service are our different types of nodes or node pools. Basically, everyone gets access to the same Kubernetes control plane managed by OCI. The only difference there is the features that are unlocked for basic versus enhanced clusters. But really, the biggest difference is in terms of your day-to-day operation of OKE clusters come with the node types. On the left side here, for more agility, for less management responsibility, you have virtual nodes. On the right side, for more control and also more manageability, you have self-managed nodes. And then right in the middle, that kind of sweet spot of agility and control, the longest standing type of nodes that we've had are what we call managed nodes. And don't worry if you haven't heard these terms before, I'm happy to share some more information about them over the next few slides. So to begin with, virtual nodes. Virtual nodes, if you're trying to think of them simply, they're just a serverless Kubernetes experience. You do not need to access the host. In fact, you have very limited access to the underlying node host. But the great thing about that is it means that you have drastically simplified operations of your cluster. You don't have the need to patch the host anymore. That's taken care of. And when I say patch, that's referring to the host OS, also the Kubernetes patch version and minor version. You no longer have to scale your infrastructure. A big part of running applications and containerized infrastructure on Kubernetes is the fact that the underlying infrastructure can scale very elastically. However, in order to do so, you typically will have to implement projects like the cluster autoscaler or Carpenter or Kada. And in this case, we're doing all that scaling for you, so it's not anything you have to worry about. Additionally, because you don't have access to that host, you don't have to troubleshoot that host, which means that yet another layer of responsibility is removed from you and falls to us as the provider. The nice thing is that even though you are vacating some degree of control, we're still providing a great degree of flexibility for you. So if you wanted to, you can choose the different types of processor shape under the hood, which allows you to co-locate more pods on the same box. There's also high vertical scalability. You can choose between ARM shapes or x86 shapes, and then also do things like leverage topology spread constraints to schedule your workloads. The cool thing about this type of node pool is that things are also cost optimized. So instead of paying for a node, which could be a virtual machine or a bare metal machine, instead what you're doing is you're paying for the resources used by your pods. So when you schedule pods within the pod spec, you'll do things, hopefully, because this is a best practice, where you schedule the resource limits and reservations for your pod. So basically, the amount of compute, CPU, and also RAM that each pod needs. And based on those reservations, that's what you're being charged for. So it's not being charged for a box that you're not necessarily leveraging to its full capacity. Instead, it really is pay per use. And the last thing that I would note is that this model also comes with enhanced security. So each pod actually sits in its own virtual machine. So there's no shared hypervisor. And that means that you have pod level workload isolation, which can be really helpful for multi-tenant use cases. And before I move on, just to key in on the diagram on the left side, you can kind of see here which parts of it are Oracle managed and which are customer managed. So in this case, you are really just responsible for kind of the Kubernetes API level. You probably would want to do things like set horizontal pod autoscaler to dynamically increase or decrease the number of replicas of your pods. But everything below that, everything, of the Kubernetes data plane, the Kubernetes control plane, the infrastructure running underneath, all of that is Oracle's responsibility, which means you no longer have to care about it. So the next type of nodes, managed nodes, are available to both basic and enhanced clusters. I should have said this again on the last slide, but virtual nodes are something that's restricted to just being used by enhanced clusters. Managed nodes are suitable for the majority of use cases. They're the node type that we launched with. They're the node type that comes with the kind of greatest balance between flexibility and management on Oracle's part. They have a very, very flexible data plane. We have a number of shapes supported. This includes x86 architecture, ARM architecture, also things like preemptable capacity or reserved capacity, GPU shapes, bare metal shapes. And a lot of these shapes end up being shapes that are not yet supported by virtual nodes, or even functionality that's not supported by virtual nodes. So for example, virtual nodes today don't support daemon sets. They don't support kind of those host level customizations, like being able to leverage custom cloud in it. And managed nodes absolutely do so. In contrast to virtual nodes, you do have to implement things like cluster autoscaler to manage the infrastructure level scale out. But there's also functionality built in. So you can do things like cycle all of the nodes within a managed node pool to apply updates to that node pool. Whenever you want to change Kubernetes version, OS version, change the custom cloud init script, change the shape of the nodes, change the boot volume size, any number of those parameters. So once you make that change, you simply hit the cycle nodes API or the button in the console, and it will automatically apply those changes to all the nodes in your pools. You can also, of course, customize your node image. You're not stuck with just the default OKE node image. You can go in and create a custom image based on our image with whatever you'd like to bake in. And then also do things like add in startup scripts. So if you wanted some particular action to take place when you boot the node, you can leverage a startup script to do that. Also, we provide complete control for hardening. So once you take our OKE image, you can really do what you want with it because it's got all of our bootstrapping scripts baked in, which allows you to harden for higher security use cases. This is what folks in our national security regions do. And if you look at the left side again, the delta between this slide and the previous one was that more components of this are shared response or to have a shared responsibility. So for example, the data plane upgrade is done by you and by us together. So we provide functionality, but it's an actual action that needs to be triggered by you. Compute resources do need to be scaled by you, but that also means that you have control over how and when they're scaled. So managed nodes, again, are probably the most commonly used node type and have quite a lot of flexibility baked in. But for the single most flexible approach, there are self-managed nodes, and self-managed nodes are also exclusive to enhanced clusters. What's really cool about self-managed nodes is that you can take any OCI compute instance or instance pool, and you can bring them to a cluster as a worker node. So that means that you have complete flexibility. Previously with managed nodes, we only have limited support over compute shapes and images provided by compute. I say limited, it's like almost all of them, probably 90% of compute shapes are supported. However, for those remaining shapes or for instance pools or RDMA cluster networks, now you can bring them to be worker nodes as self-managed nodes. What's nice about this also is that from the instance metadata running on those compute instances, we actually can inherit Kubernetes labels, which then you can leverage for things like pod scheduling. Pod scheduling, of course, is like one of the most key values of Kubernetes. It helps you organize where workloads are going to land on physical hardware. And in the case of things like workloads requiring RDMA cluster networks, like HPC workloads, you can very granularly schedule how they're going to all land together on the same pieces of physical hardware. What's also nice about this approach is that we still get node metrics and logs emitted to OCI monitoring and logging. So there's a degree of built-in observability. And then also, again, drawing attention to the left side, you can see here that this one has kind of the greatest degree of customer responsibility. So because you're bringing in compute instances and configuration options that are sort of beyond the scope of the OKE API, that means you're assuming the most responsibility. On the flip side, it does give you that great degree of flexibility. You can use any of the compute cloud engines that you want to run on this box. You can leverage these really high performance cluster networks. There is a lot of really cool functionality built into this approach. And you still do get to benefit from the fact that the control plane is managed by Oracle. And what I can also share is that self-managed nodes and managed nodes can exist within the same cluster. So if you have some workloads that require these very high performance shapes or some sort of advanced configuration, you can use those for that type of workload. And for workloads that can leverage managed nodes in which you want to give more of that responsibility to Oracle, you can still use managed nodes for those use cases and don't have to have discrete clusters for each one. Cool. So now shifting gears from node types into features. One of the core features of enhanced clusters is what we refer to as node cycling. And node cycling is specifically for managed nodes. So the way that our node pool API works, you can change the properties of a node pool, which could be Kubernetes version, the image, the shape, the boot volume size, the custom cloud init script, the SSH key, any number of properties. But those properties only apply to shapes created after you create the property or change the property. So what that means is it doesn't apply to all of your existing nodes in the cluster. And that's by design because we have a lot of customers who want to have very I guess just a lot of control over the node replacement process. You know, for some workloads, especially stateless workloads or stateful workloads, you need to have kind of an extra layer of control over when things are getting spun down and when new workloads are getting scheduled. So we wanted to separate changing those properties from applying those properties. But with node cycling, we basically give customers an easy way to orchestrate the replacement of all those existing nodes with nodes running updated properties. Also, along with this functionality comes a couple of different levers that are accessible to you. So, for example, one to control downtime is what we refer to as max surge. Max surge effectively allows you to add additional nodes to a pool so that your workloads don't suffer downtime when some of those nodes go offline and are replaced by new nodes. Another option, another lever is max unavailable, which allows you to specify the number of nodes you're comfortable going offline simultaneously in order to be replaced by nodes running the updated parameters. So those are two different ways where you can, basically provide space for new nodes to come online in your cluster. One thing that I would also call out is that node cycling respects the eviction grace period that you set on your nodes. We have this concept eviction grace period, which basically provides you a predetermined amount of time during which we allow workloads to be evicted prior to when that node gets terminated. So the idea there is we're kind of enabling a safe deletion of workloads or of nodes within the cluster. Similarly, this also respects pod disruption budgets, which are really useful for ensuring your application doesn't incur any downtime during the node termination and replacement process. One service that we have, or one feature that we have a little bit further off in the roadmap that I'm very excited about, that's also restricted to enhanced clusters, is what we call container governance. So within the space, within the container space, there is so much to know. I feel like I have to acknowledge that I'm never even going to learn everything there is to know about my own service, let alone everything else going on in the ecosystem. But just because it's complicated doesn't mean that security professionals don't still have to apply and adhere to industry standards. So that's where things like container governance and CloudGuard come in. So container governance basically allows you to reduce the complexity of managing all these different compliance standards and adhering to industry best practices by basically allowing you to bring kind of a template of those policies to your cluster. It gives you an option to audit your cluster for security best practices, and then also to even apply those standards to your clusters to basically prevent those policies from being violated. It also is integrated into the CloudGuard feature, which is another discrete service within OCI, which helps with reporting. I should also add that all this is applied remotely, so it doesn't increase the cost of operating your service if there's no additional data plane capacity required. And anyway, I just think it's a very cool feature to make sure that your customers or your clusters are secure and adhering to best practices. One of the other core enhanced clusters features are cluster add-ons. So cluster add-ons are simply just a list of operational tools deployed to Kubernetes clusters that are kind of just based on a list of things that we've seen a lot of our customers use. So for example, a lot of customers will deploy a cluster autoscaler for that managed node level of automatic scaling of your node pools. We also saw a lot of customers do things like deploy the database operator, deploy Istio. And so what we've done is created add-ons, which basically we build, test, and ensure are compatible with OKE. And you can just deploy those to your clusters with a single click. What's also nice about them is you can opt into automatic updates, which means that the lifecycle of these add-ons is managed for you by OKE over time. So every single time a new version of Kubernetes rolls out or a new version of the autoscaler rolls out, if you've opted into those automatic updates, you don't have to be the one to go in and manage the lifecycle, deploy a new image, keep things up to date, ensure there's the right number of replicas. All that is done on your behalf. The other cool thing about this feature is that you can gain more control over essential add-ons that are already deployed to your cluster. So if you were to create a brand new OKE cluster and run kubectl get pods on your kube system namespace, you'd see that there's already a few things running, like core DNS, kube-proxy, your CNI. And this, for the first time, allows you to gain control over those essential add-ons and make customizations to them, which I think is a very powerful feature for our more advanced users. So one example of an add-on is cluster autoscaler. This is something where you can deploy it to your cluster. You don't have to build the image from scratch or import our image. You can just very easily click, apply or enable within the console and have this deployed to your cluster. Also, you can use this to manage, you can use the add-on functionality to manage a lot of common parameters that customers pass in to the cluster autoscaler. Obviously, like the node pools you're trying to manage. You can use affinity, taints and tolerations to control the nodes onto which the cluster autoscaler is deployed. And then also just run certain other common configurations, all of which are available as part of our API. And I should say, for those who are not familiar, cluster autoscaler is used to automatically right-size the managed node pools in your cluster by basically tracking unschedulable pod requests. So when there's not enough resources to run all the pods are trying to scale or schedule, new nodes will be added. And if cluster autoscaler finds you have too many nodes to run all the workloads that you have, it'll actually remove nodes as well. Another one of those add-ons available to enhance clusters is the Istio service mesh. So Istio is becoming one of the most popular service meshes, probably is the most popular along with Linkerd. And this provides customers the ability to deploy Istio to a cluster with a fully managed lifecycle. And so that means that you don't have to worry about the control plane of Istio because we're sort of tackling it for you. And also we're handling the automatic proxy injection to whatever containers you have running in the environment. Just like cluster autoscaler, common Istio parameters are available for you to configure via those key value pairs, and also using the Istio command line as well. So in the interest of time, I'll run through some of the next few more quickly, and then I'll pass it over to Brian. But one of the features that's available to both basic and enhanced clusters that is a really great way for customers to create a more cost-effective data plane is preemptable worker nodes. So preemptable worker nodes just leverage preemptable virtual machines, which are kind of equivalent to AWS spot instances, which can be reclaimed by OCI compute at any time. So they're really useful for interruptible workloads. But in exchange for the fact they can be reclaimed or preempted, they come with a built-in 50% discount, and that's regardless of shape or region. So this is pretty cool if you have workloads that are interruptible. And because, again, of the Kubernetes scheduler, you can specify which of those interruptible workloads you want running on these instances using Kubernetes labels, taints, and tolerations. Another feature that's available for both basic and enhanced cluster is the native ingress controller. So this native ingress controller was created to more tightly couple sort of external access to clusters to the other Oracle virtual cloud networking services. So previously, folks would use Nginx and other sorts of open source ingress controllers. Those are still completely available for you. But the native ingress controller is something that is fully supported by us, tested by us, and more tightly integrated with Oracle virtual cloud networks. What's great about ingress controllers is they're terrific for the way that you route incoming traffic to the appropriate service within a cluster. They're also already integrated with the OCI certificate management service, which is really helpful for adding certs. And they really just allow you to simplify operations and save costs over externally available or third-party ingress controllers. Another feature of enhanced clusters is workload identity. This is one of the ones that I brought up towards the beginning. So workload identity is a very helpful feature for improving your security posture. So the way that it used to work is if you wanted to grant access to Kubernetes pods to make calls to OCI resources using the OCI API, you had to grant access to every single pod running on a node because it was a node level of granularity. With workload identity, it's no longer a node level of granularity. Instead, it is a pod level of granularity. So you can grant access just to specific pods that are serving your application, which really helps you apply the principle of least privilege to your workloads. One example of why you would want to use this is perhaps you have a pod that you need to write or read from OCI object storage. With workload identity, you can enable just that pod to write or read from object storage instead of having to allow every single pod on the same box to do that. Another newer feature that's available to both basic and enhanced clusters is our network path analysis tests. So one thing that we noticed we were getting a lot of support tickets related to is networking. Kubernetes networking, I recently saw on the new stack is just always referred to as kind of the black box. It's not an easy thing to grok. But with the network path analysis tests, we provide customers a kind of self-service mechanism to troubleshoot network misconfigurations. So these help you pinpoint connectivity issues. And more importantly, after they pinpointed the issues, provide actionable insights for how you can fix those missing configurations. And under the hood, it's powered by the Oracle Cloud Network Path Analysis tool. All right, we're nearing the end of features. Then I'm going to dive into AI ML, and then I'm going to pass it over to Brian. Okay, so with the last two, credential rotation. This is a big one because this is a mechanism for customers to rotate the root certificate authority keys and all the certs signed by those keys for the Kubernetes cluster. Kubernetes uses these certs to enable TLS within the cluster, which is important to secure communication to the cluster, from the cluster, and within the cluster. And why is this important? This is important because root CAs expire every 5 years, which means that, believe it or not, we have customers that actually have clusters that are over 5 years old. So they needed a mechanism to rotate those CAs. Also, we're starting to see more customers try to take a more aggressive security posture. And so they leverage this feature to rotate their root CAs more often. And then the last bit, logging. OCI OKE does offer multiple different types of logs, audit logs, which are useful for monitoring user activity, service logs, which are our newest log type, which provide access to logs emitted from the Kubernetes control plane components, including the scheduler, the Kube controller manager, cloud controller manager, and also Kube API server. And those are very useful for troubleshooting kind of control plane level issues. We also do support application logs. Those are custom logs captured in the OCI logging service. And of course, not stated here, but application logs can also be configured and captured using open source tools like Elasticsearch and FluentBit, which is something that was a very common pattern that we both use internally and also see a lot of our customers do. All right, now the fun part. So one of our more recent areas of attention is running AI ML workloads on top of OKE. But before I talk about that, I wanted to talk about why people are running these workloads on Kubernetes to begin with. So Kubernetes, as we talked about at the top of the presentation, is just the de facto standard for cloud-native development practices, including deploying, managing, and scaling workloads across distributed systems. Its strengths as a tool for orchestrating these containerized workloads really make it a common solution for machine learning. It handles things like node management, it handles things like load balancing and storage mounting, all of which apply to AI and ML workloads as well. And default Kubernetes patterns like jobs, which are used to run containers to completion and then release resources, are really useful for this type of workload because AI and ML workloads typically will run for a fixed period of time and then stop. And it's important for those things to typically start and stop together. Also, Kubernetes is portable and flexible. As we talked about also at the top, it's very easy to move your workloads from one provider to another or from one type of environment to another. So you can move things from development and testing to your prod environment without a lot of rewrites. Also, the fact that it is flexible means that you can leverage whatever your chosen tool chain is via just running it in a different type of container. Also, Kubernetes is efficient and scalable. It makes it easy to provide granular control over where resources are scheduled, kind of how you're allocating resources to AI and ML workloads or to the GPU resources under the hood, which is something that not a lot of other tools can do with quite this level of ease. Because of the Kubernetes scheduler, you can really optimize the use of high performance infrastructure. In fact, if you use topology constraints and you use a system that is topology aware, you can make sure to even co-locate workloads, not only on the same box, but on the specific socket running the CPU to the closest piece of physical memory running next to it, which is really important for this type of workload. And also, as I mentioned before, Kubernetes is a very active community. So between Kubernetes and the CNCF, there are tons of contributors that are all looking to leverage the tool for new use cases like this one, and to solve new problems. So for example, we've seen the batch working group pop up, which helps with batch scheduling. We've seen Q, which is another SIG within the upstream process or within the upstream service, which also is sort of scheduling and also generally AI and ML use case related. And then the last thing is it comes with this rich ecosystem. So you see projects like Kubeflow, which is designed to help with the entire process of AI and ML workloads. You see Volcano, which is a custom scheduler that improves upon the limitations of the Kubernetes scheduler to add things like gang scheduling and other common AI and ML scheduling practices. And then also other features like Prometheus, which has become the kind of de facto standard for monitoring. Prometheus has been extended to support AI and ML by capturing resources or metrics from GPU workloads as well. All right, well, we're nearing the end of my part. So now we've talked about AI and ML on Kubernetes. I wanted to talk about it specifically on OKE. So OKE provides access to specialized hardware. We have a very tight partnership with NVIDIA in which they actually not only provide their infrastructure, but also train their models on us. Also, Cohere is another type partnership that we have, also a group that is deploying models to us. And OKE provides access to all of the specialized hardware that these folks are running their models on. So leveraging self-managed nodes, customers can create cluster networks of H100 shapes, A100 shapes, A10, and other GPU shapes, and run these incredibly intensive workloads using Kubernetes as the container orchestrator. And the types of workloads they're running include developing models, also testing the models, and serving the models, which is doing things like inference. Also, one thing that's beneficial leveraging OKE is the fact that it's so tightly integrated with other OCI services. So you can connect these things to the DevOps service, which helps you with a CI/CD pipeline, with monitoring, with autonomous databases if you need to capture that data somewhere. And then under the hood, all of that is connected to RDMA clusters, compute VMs and VMs, and then also storage as well. And it is worth sharing that 100% of the AI services offered by Oracle are deployed and built on Kubernetes. This started with the Vision service. They tried using their own platform to deploy things and very quickly hit scaling issues. Then they segued to leveraging OKE and found out that, in fact, they had a 10x improvement on throughput by shifting to Kubernetes running on OKE. Along the way, they found that there's still lacking functionality from Kubernetes, so they started bringing in this rich ecosystem of features. When they needed to start serving their model better by having kind of greater scalability, they leveraged Kata. When they needed to spin their models down to zero for cost efficiency, they started leveraging Knative. And also when they wanted to monitor their service, they started using Prometheus and Phantoms. So suffice to say that Kubernetes became the kind of platform of choice for AI services within Oracle. And now that you've heard from me for the last 45 minutes, I'm going to kick it over to Brian to talk more about pricing.
Right on. Thank you very much, Mickey. You're doing a great job. I'm going to have just maybe half a dozen slides or so on pricing, which really is one of the key competitive differentiators of OKE. Because Kubernetes is an open standard, standards-based, the workloads are portable, the fact that it's easy to migrate workloads from other environments into OCI makes this pricing element something that you want to pay attention to, because if you can run a workload for significantly less financial outlay, then that's something you may want to consider for your operations. And as we go into the next slide, I just want to say that the pricing model that we use is consistent with what other providers use, but the values, the dollar amounts are quite different. So the way you calculate the price of OKE are basically these three factors shown here: the node type, and Mickey went over this, virtual, managed, or self-managed nodes. We recommend virtual for most workloads where you don't have to have precise specific control over the parameters. So for many use cases, virtual nodes will suffice. There's the cluster type, which Mickey went over, basic, enhanced. Most customers are going to want to use the enhanced cluster type to have all the feature access that he just went over. Basics is fine for kind of kicking the tires, so to speak, maybe doing a minor bit of development, but frankly, you're going to want to have access to those rich set of features, which is all comes with the enhanced cluster type, as well as self-managed nodes that requires the enhanced cluster type. And then the compute shape and resources. The great thing about OKE is you literally have access to all the different compute shapes available to you from OCI Compute. With self-managed nodes, you literally can use everything that we've got. So that includes the high performance NVIDIA GPUs, the H100, A100, and so on, as well as the RDMA cluster networking, very low latency type things. So that's all available to you with the self-managed nodes. And then there's also the tried and true, the Intel, the AMD, the Ampere shapes, all those available to you. So if you go to the next slide, Mickey, I just show this slide is going to build. This shows the cost estimator available on the Oracle website. And if you advance one, so the first thing you do, as I mentioned, you select the node type. So it defaults to virtual nodes, but there's a little drop down. You can select manage or self-manage. Then the second step is you select the cluster type. Again, it defaults to enhanced because that's what we recommend for most, but you can select a basic. And then the third step is selecting the compute shape and type. And here's where you have access to bare metal instances, virtual machines. You could select, dial in very specifically the OCPU and memory. And this is another differentiator with Oracle OKE in particular, is the flex shapes. You can specifically specify how many OCPU and how much memory. And there are limits in terms of like the ratios, but basically you have very broad palette to select precisely what you need for your workloads. It's not a matter of sifting through hundreds of different instances to figure out which one is right for you and for your workload. With flex shapes, you can just dial up and down the OCPU and the memory to get exactly what you need for your workload. And then lastly, for even the greatest amount of configuration, you can specify the number of hours per day, number of days per week, that type of thing, to get a very specific cost estimate. For the price comparisons themselves, you can see I mentioned that the model is consistent with the other hyperscalers, but the key difference is the numbers, the absolute value of the costs. And what we're showing here on this slide is a comparison of the various costs for the services in our competitors' lowest cost regions. So this is another differentiator of OCI in general, and it applies to OKE, is that it's the same price in every region. So with our competitors, typically what you see is low prices or their lowest prices in North America, but then significantly higher prices in other regions around the globe. So, higher in Europe, higher in Asia. Unfortunately, Sao Paulo, Brazil tends to have the very highest prices, and in many cases double for our competitors. But with OKE, you don't have to worry about any of that because it's the same price in every region. So it's an important differentiator. Makes it not only cost effective, but very easy to plan for a global deployment. But you can see there in that pod per node CPU column, literally OKE is a quarter of the price for a vCPU hour. And then likewise for the pod per node of memory, we're looking at about a quarter of the price per gigabyte per hour memory. So these are important material differences in the cost of things. Now, it is true that we have this very nominal charge for virtual nodes, but you can see it's only a penny and a half per node per hour. So that's, extremely nominal. Bottom line, you can save substantially with OKE versus the other guys. And in fact, over 50% less cost for running Kubernetes workloads on OKE than with the competitors. So I'll say that again, 50% savings for running on OKE versus EKS, AKS, GKE, when we're talking about virtual nodes or that serverless experience. So that is substantial. And think about all the other projects your organization could fund, the people you could hire, retain with that savings. So it's a material difference, and that's why we kind of harp on it a little bit. Next slide, please. And to put everything in perspective, it was like, oh, the control plane, there's this overhead. Well, when you really think about it, the percentage, the portion of the control plane to the overall cost for a workload is fairly nominal. For a small deployment, the percentage of overhead or for the control plane is about 11%, but for an average deployment, and I'm going to show you on the next slide what we mean by small and average, it's only 2%. So these are very nominal things. So that 10 cents per cluster per hour is in the big scheme of things, it's kind of down in the noise level. And this is why the OCI compute cost advantage is so important to pay attention to, because when you start adding it up over time, it really makes a big darn difference, and that's an important factor to take in mind. Next slide, please. So a small deployment, what we characterize this as, say, 20 pods, 2 vCPU or 1 OCPU, 8 gig of memory for a month. And you can see here, the first column, OKE, substantially less than the competitors, 2.5 to 3 times less, whether it's virtual nodes for the serverless experience or the managed nodes or self-managed nodes. Managed and self-managed, same price in terms of like enhanced clusters, and you just pay for the compute and the memory. So substantially less. This is for a small deployment. And then the next slide for the average deployment, the key difference here is the nodes themselves are larger, 16 vCPU instead of 2, 64 gig instead of 8. But still, the delta is the same, about 3 times less than the competitors. So it is important to recognize that, hey, Kubernetes is standards-based. It's the same in each environment. But if you can save like 50% or something, that's an important consideration. So something you want to think about is you're considering your multi-cloud or your hybrid deployment strategy, which workloads do you want to deploy where? OKE is very compelling in that regard. And then next slide, the wrap-up slide for me. If you want to see the numbers, the calculations behind these cost comparisons, we have it all out there in this blog post. It is from a year ago, but good news, the prices have not changed. So the prices are consistent. We just double checked this recently. And so all the calculations are there. You can see for yourself, and you can use the cost estimator to maybe run the numbers on your own configuration to see how they compare to other providers. So those are the key differentiators on the pricing and the cost comparison. Mickey, I'll hand it back to you to talk about some customer examples and then bring us home.
Sounds good. Thank you, Brian. So I'll go through this rather quick, just because in the interest of time, I want to leave some space for Q&A. But suffice to say, OKE is a platform of choice for plenty of customers. We have literally thousands of enterprise customers running on our service, and not even just internal or external customers. We also have all the AI services internally that I mentioned, and tons of other internal services running on OKE as well. And the reason we bring up internal services is just because that's one way of knowing that we have a lot of folks that are operating on us and leveraging us for sort of cloud scale applications, like Oracle Fusion apps, our Service Cloud, IoT, Digital Assistant, data flow streaming, etc. So there's lots and lots of different people. And you can see these customers range across industries. You have American Airlines, Uber, Zoom, 8x8, FedEx, NVIDIA, Red Bull Racing, for those F1 fans. So lots and lots of different folks are leveraging OKE for their container platform. And also just to race through, as Brian mentioned, there are a lot of cost savings of leveraging OKE, 50% performance boost and cost reduction, enabling Wiz to scale up to reach 100 million ARR in just 18 months, and even more savings for GoTo. So with that, I want to leave some time for Q&A, and then I will kick it back over to Nikki to close things out for us.
Awesome. Well, thank you for the great session. If you like today's session, we would love to invite you to check out our upcoming events. We'll also love to hear your feedback and what topic you'd like us to cover in the future. With that, I'll go ahead and end today's session, and we hope to see you at our next event. Thank you.